Hey, welcome back for break. It's the next chapter. We're doing math again. Hopefully you didn't forget everything. If you did, the good news is that this is a really easy chapter to kind of get it back on. We're doing a lot of the same stuff we've done before, except now we're doing it with inequalities. So what's the difference between that and an equality or an equation? Well, let's look at an example. You have 40 dirhams. 40 dirhams in your pocket. Two 20 dirham bills, whatever. Apples. So X apples cost 3 dirham per apple. How many apples can you buy? Now this is a super simple problem. You can probably think about it on your own and you could say to yourself, well, okay, like I could buy 0 apples, right? I could buy 1 apple, I could buy 2 apples. If you're thinking ahead, probably you could go all the way up to 13 apples, right? Because if each apple costs 3 dirhams, like 3 times 13 is 39. If I go up to 14 apples, now 3 times 14 is going to be 42 dirhams, and that's more than I have to spend. So, like, we could write this as our answer, if we're just kind of guessing and checking. Notice that there is more than one correct answer here. It's not just, hey, X is this one number. I'm saying, oh, hey, X could represent this whole range of numbers. I could buy the maximum amount of apples at 13, or I could buy something less, because the problem's not saying I have to use all my money. So in order to solve these problems, we're going to kind of do it just like we would do an equation. It's just that our answer is going to represent a range of numbers instead of just one answer. So let's set up the equation. In this case, 3x, that's the amount I'm spending on apples. And I'm kind of comparing that with 40, the total amount I have to spend on the apples. And in this case, 3x, it would need to be less than or equal to 40. And think about why that makes sense. The amount that I spend on apples, doesn't it definitely have to be less than the amount of money I have in my pocket? Like, I can't spend more than 40. So that 3x has to be less than. It could be equal to 40, because can't you spend all your money? Like, you can. You could spend 40 dirhams. So I have set up this equation correctly. To solve it, easy. I'm just isolating x just like I do with an equation. Let's divide through by 3. I get that x would be less than or equal to, this happens to be 13 and 1/3 if you changed this fraction into a mixed number. Hopefully you remember how to do that. So x less than or equal to 13 and 1/3. This could be my answer, but let's think about the context a little. Does it make sense to buy 1/3 of an apple? No, not really. And in fact, over here, when I was just guessing and checking, I decided that 13 was the maximum amount of apples I could have. As soon as I hit 14, I've spent 42 dirhams and I've gone too much. So in context, it would actually be better, instead of that answer, to put x is less than or equal to 13. Just recognizing the fact that I can't buy 1/3 of an apple. That doesn't make sense. Now, to make this graph, remember, I want you to show the 0, and here's 13. I'm going to make a closed dot, and the reason why I'm choosing a closed dot is because x can equal 13. So closed dot because x could equal 13. The closed means, yeah, that's a possible value. And let's think, is x bigger than 13 or smaller than 13? Well, it's smaller than 13, so I'm going to draw my arrow going to the left. This graph represents all the possible apples that I could buy. I could buy 13, I could buy 12, I could buy 11, I could buy 1, 2, because I'm shading to the left. Now, some of you are thinking, wouldn't you need to stop at 0? And yes, technically you would, because you can't have negative apples. We'll get into the kind of in-between examples. Just know for now that you're shading to the left of 13. All right, let's look at a little bit more of a simple example. Okay, the difference of n and 15 is greater than 4. So let's kind of break this down. Difference, you should know, is kind of a synonym for subtract. So I'm saying, hey, I'm subtracting n minus 15. I'm going n minus 15, and that has to be greater than 4. So whatever n is, when I subtract it with 15, it has to be bigger than 4. Now again, we could guess and check some things, right? What could n be? Well, n could be 20, right? 20 minus 15 is 5. That's bigger than 4. N could be 21. N could be 1,000. 1,000 minus 15 is a really big number that's obviously greater than 4. N could not be something like 12. Is 12 minus 15 greater than 4? No, it's negative. N could not be 16. 16 minus 15 is only 1, not bigger than 4. So I'm going to have this range of answers, and to get the exact range, literally all I have to do is isolate the n. Let's add 15 to each side to find that n is greater than 19. So this is my answer. It makes sense in the context because really there is no context here. I just need to graph it. So 0's over here, 19's like here. Since n has to be greater than 19 but not equal to 19, I'm going to show this with an open dot. Because even though n could be, even though n could be numbers like 19.5, 19.01, 19.00001, those numbers are all bigger than 19. This is bigger than 19. This is bigger than 19. This is bigger than 19. But it can't actually be 19. Is 19 greater than 19? No, it's not. So I'm going to draw the open circle to represent, hey, 19 is obviously an important number, but n actually can't be 19. Now, for my arrow, let's think about this. Does n have to be bigger than 19 or smaller than 19? Well, clearly here, because of the greater than sign and the fact that n is on the bigger side of that greater than sign, n needs to be bigger than 19. So I'm going to be drawing my arrow to the left, representing that values that work are things like 20, 21, 1,000, numbers that I already decided. Actually, 1,000 would be way over here. Anyway, numbers that I already decided would work. All right, let's do one more example. There's one tricky little rule you have to remember for this section. Let me show you what it is. We're solving this equation, and in order to isolate the x, I need to cancel this -7. Since x is dividing -7, the opposite, the inverse operation would be to multiply by -7. So if I multiply both sides by -7, multiplication and division cancel. I have x. On the other side, I have -49. Here's the tricky rule. When we are multiplying or dividing, so multiplying or dividing by a negative, we have to flip the direction. So this changes to this. So instead of a less than or equal to sign here, I need to flip it and write a greater than or equal to sign. And remember, that's because I multiplied or divided by a -7 in this case. So since I multiplied by -7, I must flip this becomes this. Okay, so that's my answer. I could make a whole video on why that's the case, but basically it has to do with the fact that on a number line, when you're doing positive numbers, they get bigger as you go to the right. But negative numbers kind of go oppositely, right? They kind of get bigger as you go down. And so since negatives are kind of getting bigger oppositely of positives, I have to flip the direction. It has to do with that. It's a little bit more complicated, but that's what it has to do with. Okay, anyway, let's draw my number line. 0 would be way up here. -49 would be way down here. Now, be careful, because there's a common mistake that I see. Oftentimes, people will be like, oh, hey, greater than or equal to sign. That means I need to draw my arrow dot. It's closed because it's equal to, and I'm going to the right, right? Is that correct? Actually, it's wrong, because take a look at this. Even though you would think a greater than sign always goes to the right, think about what's going on here. X. Isn't x smaller than -49? Like, based on this sign, it's telling me that -49 is the big one, and it's telling me that x is the small one, and small numbers aren't to the right. Small numbers are to the left, so really I need to shade this way. So don't just look at the greater than or equal to sign and say, oh, greater than, that's to the right. You have to look at where x is. Here, x is clearly the smaller number. All right, so be careful about that. Now, there are some counter examples to that multiplying by a negative rule. Here's a counter example. Let's say I had something like x plus 15 greater than 17. I would need to subtract 15 in order to isolate the x. Do I need to flip the direction here? Do I need to flip this? Because look, I subtracted by 15. I added negative 15. So does that apply to the rule? It does not, because it's not multiplying or dividing. If I just add negative 15 or subtract it, that does not mean flip the sign. So flip, no. Here's another counterexample. Let's say I have 4x greater than negative 8. Clearly, I would need to divide by 4. So that would give me x greater than negative 2. Now, hold on. I do have a negative, and I am dividing. Does that mean I flip? Should I flip the direction here? And the answer is, again, no, because even though there's a negative here, I'm not dividing by that negative. So since I'm dividing by a positive 4, I need to not flip. So you only flip if you have something like this where I'm dividing by negative 4. Here's the situation where I would flip. So hopefully that rule makes sense, and we'll practice it plenty more. All right, so summary. If multiplying or dividing by a negative in solving, you must flip the direction. So if you have this, it becomes this. If you have this, it becomes this. You have to flip the direction. An open dot. When do I do an open dot? Well, that would be if I have a greater than sign or a less than sign. Closed dot, remember, is showing, hey, this number actually can equal x. So that's where I have a closed dot. So open dot, closed dot. All right, for graphing, look to see if x is bigger or smaller than the number it is compared with. Do not just look at the greater than sign and shade to the right, kind of like we did in example 3. You must look to see, hey, x is the smaller number, so I'm going to shade to the left. Don't just look at the greater than sign. All right, hope you liked that video. Hope you made it through the whole 13 minutes. Hope you actually listened to it, because otherwise it was probably not very useful to you. Don't get into the habit of not listening to these videos. Very, very important. Cheers.